Last week we started looking at trigonometry, and we found out that you can solve right angle triangles using SOHCAHTOA, right? And SOHCAHTOA was sine, cos, and tan. Those were really just tables that showed you the ratio between angles and side lengths. Now the problem is that those tables, and those tables are built into your calculator, those tables for sine, cos, and tan only work if it's a right angle triangle, if it's a triangle with a 90 degrees in it. So what happens when you run into a triangle that doesn't have a 90-degree angle, like this one here? Right, this angle is bigger than 90 degrees, right? Normally the 90 degrees is marked with a little box, right? And obviously this angle is larger, so in this sort of scenario, you cannot use SOHCAHTOA. But there are other relationships. So the one we're looking at today is called the sine law. So in this sort of scenario, you would have to use the sine law. And the sine law is just an equation which gives, once again, a relationship between angles and side lengths. This one is nice, though, because it works for any possible triangle, even if it doesn't have a 90-degree in it. So you can come up with this equation in a few different ways. I'm not too worried about deriving the equation, but you could actually get it by just looking at a bunch of triangles and going through and measuring lengths and angles, and you could find it that way. So when we look at these sort of questions, the first thing to do is to label your triangle. We label it a little bit differently when it's not right angle. It actually doesn't matter which side is which. I usually make A my unknown, just to keep things easy. So if my unknown is a length or an angle, I'll make that one A. The only thing you need to do when you're labeling it is you need to make sure that the angle A is always opposite across from the length of A. And we use capitals for angles and lowercase for length. So here I've decided that angle A with a capital is across from lowercase a, length A. And I'll make that guy B. Angle B with a capital is across from length B, lowercase b. And angle C, capital C, is across from length C. So when I'm labeling these, I just make sure to use capitals for angles, one at each vertex, each corner. And then across from them is the length using a lowercase. You can label it however you want, but make sure that these are always across. A is across from A, B is across from B, C is across from C. And you're usually best to make A your unknown, your X or your theta, if that's what you're trying to find. So what the sine law says is that if you take length A and divide by sine of angle A, that will give you a ratio. And that ratio will be the same as length B divided by sine of B. And that ratio will be the same as length C divided by sine of C. So these three ratios will always work out the same. So what you can do is you can label your triangle, and then you can just use whichever ones are needed, right? So if A and B are the important ones in that question, you would just use that part of the equation. If A and C are the only important sides, you would just leave this out, and you would just use the first and last part of the equation. So you can set any two of these equal to each other. Now, because these are just single fractions in each part of this equation, you can actually flip each fraction upside down. You take your entire equation and flip it upside down. That only works because it's a simple fraction. So you could instead write the equation the other way around. So sine A over length A equals sine B over length B equals sine C over length C. Either way is fine. Usually I use this one if I'm looking for a length. That way my length is already on top. And I'll use this one if I'm looking for an angle. That way my angle is already on top. It just makes it a bit easier to solve because then you don't need to worry about your unknown being in the denominator, in the bottom of the fraction. So let's do some examples here. All right, first example. All right, so I immediately notice no right angle, so I have to use sine law now. I can't use SOHCAHTOA. And first thing I do is label it. So I like to make a's my unknown. So this will be my length. I'm looking for a length here, so lowercase a for length. And across from that is my angle A. So angle A is 40 degrees. And then I'll just make the other one B. So we'll say that's length B. And across from length B is angle B. So you'll notice I made A my unknown. My A is across from A. My B is across from B. Lowercase for lengths. Uppercase for angles. And in this case, it looks like I'm solving for a length, so I will use the format that has the lengths on top. And A and B are the important ones, so I'm just going to use that part of the equation, the A's and the B's. So A over sine A equals B over sine B. And at this point, it comes down to just plugging in what we know. So let's substitute everything in. So my A is an X, and sine of angle A is sine 40. So that turns into X over sine 40. My B is a 20, so 20 over sine B, which is sine 100. So 20 over sine 100. All right, so I plugged everything in. Remember that sine 40 and sine 100, those are just decimal numbers. So you can solve this equation just like any regular equation and just treat those as if they're numbers. So in this case, I'll rewrite it one more time. In this case, we want to solve for x, so what do we need to get rid of? The sine 40. Okay, opposite operations. Sine 40 is dividing, so to move it, we will multiply by sine 40 on both sides. That cancels it out over here. Okay, so that leaves me with x equals 20 over sine 100 times sine 40. So we'll plug that into our calculator here. Let's see what we get. So 20 over sine 100 times sine 40. So 20 over sine 100. We can work that out. And then times times sine of 40. And that came out to, that would round to 13.1. So just make sure that the calculator is in degree mode, right? So if you're getting different numbers and you're plugging that in, just make sure to change that calculator to degree mode. If it says like RAD, radian mode, if it says that in the top left of your calculator, you'll need to change it there. You usually have to do like second something to change it. But you can send me an email if you're having trouble with the calculator mode. So it should come out to about, so 13 rounds to 13.1. There we go. All right, let's do one more example. All right, next one. Once again, I quickly look at this and I say, there's no right angle triangle. I cannot use SOHCAHTOA. We're going to use sine law instead. And we start by labeling. So let's see here. I'll make A my unknown, and it looks like angle A is my unknown, so capital A over here. Across from that would be length A. And then I have the other one, I'll say angle B, and across from that, length B. Once again, A is across from A, B is across from B, capitals for angles, lowercase for lengths. Okay, this time I'm solving for an angle, so I'll use the form that has the angles on tops. And it looks like A and B are the important ones again. So I've got sine A over A equals sine B over B. And let's plug in what we got here. So sine A becomes sine theta. Length A becomes 11.2. Sine B becomes sine 55. And length B becomes 11. All right, so we're left with this guy here. There's only one unknown, just the theta is the unknown angle. So we should be able to solve this. We need to eventually get that theta by itself, right? Let's write it one more time here. Okay, so getting the theta by itself, we need to move everything else over. So let's start by moving that 11.2. Right now 11.2 is dividing, so we will multiply 11.2 on both sides. That will cancel it out here. And that leaves us with, so we're now left with sine theta equals sine 55 divided by 11 times 11.2. And at this point, remember, if you're solving for an angle, that's where you use an inverse sign, right? So you know what? Let's work all of this out first. This is all just numbers over here, right? So let's work out what that is, and then we'll go from there. All right, so sine 55 divided by 11 times 11.2. Sine 55 divided by 11, and then times 11.2. All right, so that came out to 0.8340457. All right, so I'm going to keep several decimal places because when I do that inverse sign, I don't want to run into any rounding errors. So in this case, I got 0.834. I think I'll keep a few more decimals here. And at this point, you need to move the sign over by doing that inverse sign, right? Sine -1. Inverse sign of our decimal number. Anytime you solve for the angle, you move that sign over by doing inverse sign. And inverse sign just looks it up backwards in the table, right? All right, so you usually have to press like a second button, right? So second sign to get the inverse sign of 0.834. And I might keep a few more decimals just to be sure. Okay. And we got 56.5 degrees. All right, 56.5 degrees. So now that's the angle. So these questions are quite similar to the SOHCAHTOA. It's just a different relationship, right? You have to use the sine law equation now. And make sure that you're labeling it correctly at the beginning. So lowercase for length, capital for angle, and A is always across from A, B is across from B, C is across from C. So at this point, there are a few practice questions for you guys to do. And there's also one or two word problems. So the word problems, just make sure to draw out a diagram. And then from there, you should be able to label it and see what you're solving. One of the other tricks you might run into is that all of the angles in a triangle add up to 180. So sometimes what you'll need to do is if you know two of the angles in a triangle, you automatically know the third one. Right, subtract from 180. So sometimes if you don't have the one that you want, if you know two angles, you can actually just get that third angle.